Anything you build from the bottom up, and anything you take apart from the top down. That is not a rule somebody invented. It is just gravity, and it has never needed defending. But above a certain height, some of the machines that do the taking apart run out of building to stand on. Think about how a tower actually comes down when nobody is using explosives. You need a crane above the work. The crane is bolted to the structure. Every floor you remove takes away a piece of what the crane is standing on. So the machine has to descend as the building descends, and it has to keep lifting steel the entire way. At first, this might just seem like a problem for somebody in the year 2200. It is not. It is a problem for whoever signs the maintenance budget this year, because a building with no exit is a building that somebody has to pay for without an end date. So how tall is the tallest building anybody has ever actually taken down on purpose? And why is the record holder standing in New York rather than anywhere in the Gulf? You have walked past scaffolding on a building and assumed it was temporary. You have seen the plywood hoarding, the plastic sheeting, the cradle hanging off a parapet, and read all of it as a phase that would end. Above a certain height, that assumption stops being safe. The cradle is not a phase, it is a condition, and it is permanent. The Burj Khalifa opened in January 2010. It is 2,717 feet tall, and it has 163 floors above ground. Every number published about it during construction was a record. Almost nothing has been published about the other end. Ask the same question of any tower over 1,000 feet, in any country, and you get the same silence. The people who designed them are structural engineers, and their job was to make something stand. Nobody hired anybody to work out how it stops. There was no line in the budget, no client asking, no regulator requiring it. To understand what that means, you have to stop looking at how the tower went up and look at what is known about bringing one down. The answer is smaller than you expect. So why does a record set before the moon landing still stand? For most of the 20th century, the record belonged to the Singer Building in New York, 612 feet, taken down floor by floor in 1968. For decades that stood as the tallest building ever peacefully demolished. You have stood next to taller buildings than that, without once looking up. Picture that job. Men on a wooden deck, cutting a steel frame apart with torches, lowering it into the street with a derrick, in a New York with no computers. It was beaten in our lifetime, and again in New York. The tower at 270 Park Avenue, 707 feet, 52 stories, opened in 1960 and taken apart between 2019 and 2021 to make room for a bigger one. It became the tallest building ever, voluntarily dismantled. Nobody did that for engineering reasons. They did it because the land was worth more than the tower standing on it. Now put that against the Burj Khalifa, 707 feet, against a tower nearly 4 times as tall. The tallest building this industry has ever proved it can take apart would not reach the Burj Khalifa's 100th floor. What follows is that gap being taken apart, one constraint at a time. This channel exists to take apart systems like this one, so if that is what you came for, subscribe and stay with it. Picture the site at 270 Park Avenue on a weekday morning. The tower is wrapped in scaffolding and netting, and the top 3 floors have no walls left. Inside, a crew is working under a temporary roof deck so that nothing they cut can fall to Park Avenue below. There is a crane on the roof, and it is smaller than the one that built the place, because it has to be able to lower itself. The foreman running that deck has a different job from the foreman who put the building up. He is not assembling anything. He is holding a structure in a half-finished state, at height, in weather, with traffic underneath, and every piece he removes changes the load path of what is left standing. He cannot close Park Avenue. He cannot work in high wind. He cannot cut a beam until a surveyor has confirmed what that beam was carrying and where the load will go instead. The rules he is working to are written down. In the United States, safety requirements for demolition operations sit in ANSI/ASP A10.6, a document argued over by a committee of people who have stood on decks exactly like this one, and it decides things as specific as when a floor may be used to store the debris taken off the floor above. Above him, another worker is cutting bolts with a torch, catching each one in a canvas bag, because a single bolt dropped from 400 feet is a fatal object. Roughly 185,000 tons of that building came down that way, piece by piece, into trucks. Almost all of it was recycled. It took about 2 years. 2 years, for 707 feet, on flat ground, in a city with 60 years of experience, doing exactly this. Somebody paid for those 2 years, and that is the part of this story that never makes the height records. Start with the owner. Ordinary commercial property is valued with a residual in it, which is a polite way of saying that at some point the building stops and the land continues. Remove that assumption, and the maintenance obligation runs to the horizon. Facade access equipment, lifts, pumps, fire systems, the cooling plant, the anchor bolts that hold the cradles, all of it renewed on a cycle, forever, with no year in which the spending stops. There are 3 walls, and each arrives at a different point, but something sits in front of all 3. It is the constraint almost nobody mentions, which is how you get people and material up and down while the work is happening. On a normal demolition, the crew walks. On a tower of this size, the crew rides, and the lifts run in shafts that are part of the structure being removed. So the last thing you can take out is the thing everybody depends on to be there. Ask a rigger what that means in practice, and the answer is a schedule problem, not a physics problem. How many people can you get to the working floor in an hour? How much steel can come down in a shift if every piece has to travel in a lift car? At 700 feet, you can put a hoist on the outside of the building. At 2,000 feet, in Gulf summer wind, an external hoist has its own weather limits and its own queue. Now the 3 walls. The first is the crane. A tower crane climbs by jacking itself up and inserting new mast sections beneath. Reverse it, and the crane must remove its own mast while carrying steel, and each removal happens on a structure that is being progressively weakened by the same crew. Below roughly 600 feet, this is routine work. Above it, the machine spends more and more of its capacity holding itself up rather than lifting anything down. The second wall is the top-down method, and it is the most elegant answer anybody has produced. 2 Japanese contractors built systems for it. Kajima developed what it called cut and take down, which removes floors at ground level and lowers the whole building on jacks, so the roof stays where it is and the tower shrinks underneath it. Taisei built a rival system that closes the top of the building inside a movable cap and works downward. Both were used in Tokyo between 2012 and 2013 on buildings of roughly 450 feet. Read that again. The most advanced building removal systems ever built were proved at about 450 feet. That is shorter than the tower you can see from almost any window in downtown Dubai. 2 of the largest contractors in Japan put engineers on this for years, and that is where the proof stops. So why has nobody gone further? Because until now, nobody has needed to. The third wall is explosives, and this is the one people assume solves everything. It does not. Explosive demolition needs the structure to fall inside its own footprint, which needs a footprint large enough and empty enough to receive it. The record is well documented. In 2020, 4 towers at Mina Plaza in Abu Dhabi were brought down by controlled explosion in about 10 seconds. The tallest was around 540 feet, and it holds the record for the tallest building ever demolished that way. 540 feet. On a cleared site, with a wide exclusion zone, in a city that could afford to empty the district for a morning. Now try to imagine the exclusion zone for a 2,700-foot tower in the middle of downtown Dubai, where the site is bounded by a shopping mall, a lake, a hotel, and a road that carries a large share of the city. There is a fourth constraint that gets less attention. A supertall is not just tall, it is heavy in an unusual way. The Burj Khalifa uses a buttressed core, meaning the whole tower leans on a central concrete spine with 3 wings bracing it. That geometry is what makes it stable in wind. It also means you cannot remove one wing and leave the rest standing, in the way you can strip a floor plate off a steel frame in Manhattan. Take the wing away, and you have changed the thing that was holding the core steady. Every one of those constraints has been solved at some height. None of them has been solved at this one. This is where the story stops being about one city, and it is the part I think matters most. The Gulf built its supertalls in a rush, mostly after 2000, and almost all of them are still in their first operating life. Nobody there has ever had to answer the end-of-life question, because nothing has reached the end. New York has been answering it for a century. That is the entire reason the record for taking a tall building apart sits there rather than anywhere else. The Singer Building in 1968. The tower at 270 Park Avenue in 2021. In between, hundreds of smaller ones, and an industry of surveyors, riggers, and engineers who have done this in an occupied street. Manhattan is also where the newest supertall problems are being argued out in public. There are towers on that island, in litigation over facade cracking, over sway, over lifts that stop in the wind. Owners there have already found something the Gulf has not had to face yet. A slender tower can become expensive to run, long before anything about it is unsafe. The Council on Tall Buildings and Urban Habitat has a word for that state: obsolescence. Say it to a structural engineer and you will get a shrug, because it is not his department. Say it to the man who runs the building, and he will know exactly what you mean, because he is the one reading the service charge. A building becomes obsolete not when it is dangerous, but when the cost of keeping it usable passes what anybody will pay to use it. In an ordinary city, the market answers that with a demolition permit and a new plot. Somebody buys the site, the building goes, and everyone moves on. For a supertall, where do you send that answer? You cannot send it to a contractor, because no contractor has done the job. You cannot send it to an insurer, because nobody can price it. You cannot send it to the planning department, because there is no application form for it. This is not a Dubai gap. It applies to every building above roughly 1,000 feet anywhere on Earth, and there are now several hundred of them, in Shanghai, in Chicago, in Kuala Lumpur, in Riyadh. Jeddah Tower is being built to pass 3,000 feet. Not one of the people working on any of these projects has ever removed anything close to that size, because nobody has. I looked for a published end-of-life plan, deconstruction study or decommissioning strategy for any completed building above 2,000 feet, and I could not find one. If one exists, and you know where, put the link in the comments and I will pin it. You have already heard what that does to an owner. It does more than that, and every part of it has a name attached. Then the insurer, who is asked to price a risk with no defined termination. Every other structure an insurer covers has a horizon. A ship is scrapped. A refinery is decommissioned. A bridge is replaced. Ask an underwriter what a building looks like when there is no such date in the file, and you will get a long pause. Then the city. Guidance from the National Fire Protection Association, including NFPA 241, exists because construction and demolition work on an occupied site is where a great many serious incidents happen. It covers temporary fire protection, hot work permits, who holds the keys. It assumes a project with a start and a finish. It does not imagine a facade program that never ends, on a building where a torch is in use somewhere every week of every year. Then the engineer, who has to certify the structure decade after decade. The American Society of Civil Engineers publishes load standards, and ASCII 7 tells you what a building must resist. It does not tell you how many times you may re-anchor a cradle rail into the same concrete before that concrete stops holding a bolt. Nor does the guidance from the Occupational Safety and Health Administration, which governs how people work at height in the United States, and assumes, reasonably, that the work has an end. That is the recurring shape of this whole problem. Every document is written for a project. The building is not a project, it is a condition. And then the person who has to sign. Somewhere, there is an asset manager holding two numbers. One is the annual cost of keeping a supertall in service. The other is the cost of doing something about it, which nobody can quote, because nobody has ever done it. Faced with a bill you cannot price, the rational move is always to defer, and deferring is exactly how a maintenance obligation turns into a permanent one. Ask yourself what happens the first time a supertall changes hands, and the buyer's lawyer asks a simple question. What is the plan for the end of this asset? Right now, for every building above 2,000 feet, the honest answer is that there is not one. What follows is a hypothetical engineering stress test. It is not a description or a prediction of an actual event at any specific building. Take a supertall, anywhere, 40 years old, not damaged, not unsafe, simply expensive. Now stack the conditions. The facade system it was built with is out of production, and the last supplier who could match the panels closed. The lift machinery has reached a point where spare parts are being made one at a time. 2 of the 3 anchor rail systems on the roof have been refixed twice, and the engineer will not certify a third. The building is 2/3 empty, because tenants moved to newer towers with lower service charges. The owner's lender wants a 20-year plan. Now add one more thing. A neighboring plot is sold, and the new development needs the airspace above the older tower's roof for a crane. So a decision that everybody assumed belonged to the next generation arrives on a Tuesday, in a meeting room, in front of 6 people who did not build the thing and will not be there when it is resolved. Here are the questions, and I am not going to answer them for you. Who decides that a building has reached the end, and on what evidence? If the owner walks away, who inherits a 2,000-foot structure that still needs a facade crew every week? Does the city have a legal instrument that can compel anything, and could anybody enforce it? And if the answer is that the tower keeps standing and keeps being maintained, at whose expense, for how long, and what happens in the first year nobody pays? Notice that not one of those questions is a structural question. The engineering is the easy part. The tower will stand. What has no answer is who is holding it, and on what authority, and with whose money. The answers exist in outline, and they are all unfinished. Design for disassembly, which means building the next tower with its own removal in mind, and which loses an argument to the developer, because it costs money now for a benefit nobody alive will see. Sinking fund requirements, which lose to the leasing team the moment service charges get compared with the tower across the road. Mandatory end-of-life studies, which lose to the planning authority because no city wants the first line of a press release about its landmark to be the word decommissioning. And partial removal, taking a tower down to a shorter, cheaper building, which loses to structural reality, because a buttressed core does not have a natural stopping point halfway. A visitor at the observation deck sees a view and a record. An engineer standing on the same deck sees an obligation with no expiry date on it, and a facade crew who will be coming back every week for the rest of his career and somebody else's after that. Remember the scaffolding you walked past. You read it as temporary because almost all scaffolding is. On the towers that now define these skylines, access equipment is not a phase in the life of the building. It is part of the building, and it will be there for as long as the building is. That is the real story hiding behind the height records. The interesting number is not 2,717 feet. It is 707, because that is the tallest thing this industry has actually proved it can undo. Everything above that line is a promise nobody has kept yet, made by people who will not be asked to keep it. If you want to understand the hidden systems that keep enormous cities functioning, make sure to subscribe to the channel. And I want one thing from you. If you have worked on a high-rise demolition or a facade access program, what was the tallest building you personally saw taken apart, and how long did it take? Tell us in the comments below. A note on this video. What is described here is a general engineering and commercial principle, and it varies from building to building. Nothing here asserts that any named building is unsafe or is being decommissioned. The stress test is illustrative, not a report. Footage is stock. This is educational, not professional assessment.